Boy. Seriously, Pastor Earl, you didn't do your homework, huh?
I did.
Okay.
I didn't do 45. That's the only one I didn't do.
That's a 4 on the grade.
Okay, there's no force. Okay, 5.6 to 6.3a, you have a quiz on that on Monday. And probably for the first time ever, we are actually ahead of Massey's class. Yeah, so that's you guys. That's all on you. That's all you. Take the day off. Yeah, right. Not happening. Okay.
Is that why we took the day off a couple days ago?
Nah.
We didn't need to do anything.
Nah. Yep.
Good for you back then.
Good job. Okay, so your quiz is over that. Don't forget that has proofs on it. Yes, we have lots of trig proofs coming, but you see the proofs in that type of form, like these problems we're working on where you have to make those substitutions. That's why I hate the way books teach it. Like there's like, here's trig proof, something you've never done in your life. It's pretty darn hard. And now learn that all in one night, and then the next night, let's solve problems that involve trig proofs too, and that's usually when kids give up on pre-calc. That's why I've been teaching them to you for a month now. So 5.6 to 6.3a, in other words, everything we've covered this semester before today, it is a big quiz on Monday. There are going to be proofs on it. The proofs are nothing harder than you've already done before. What's that? What? Yeah, I don't have to be here for quiz day.
Why?
What's that? Yeah, suddenly everybody wants to join debate. Ha ha, very funny. Ciara. All you get for that is the odd and even properties of sine and cosine, but I'll tell you, you don't even really need them. So no, you have to know it off the top of your head. Luke.
When you said proofs, is it like solve the x?
Yo! You told me to notes on every
You said you
quiz.
did a quiz.
And quest.
Cross out quizzes for test.
How do you expect me to prepare for
Yeah.
this?
Do you have a note card?
No, back when we get that.
All right, so now Sandal and wine, people. Yeah. Okay, so Sandal did negotiate. You may use your memory sheet on there, though. That's all you can use, though. Luke.
So when you say proofs, it's like a QE.
Hey, I can't hear you. People are talking.
You say proofs like a QE
Yep.
stuff?
Yep. But I will tell you, the proofs in our book are nothing compared to the proofs you already did. So they're easier ones. Cassie. I'm sorry. Jackie.
I don't even have a memory sheet.
What's that?
I'll photocopy mine.
Jackie, you got it so easy last semester not having to memorize that, but it'll come back to
No, we
bite
had
you.
to memorize it. We just do it on a sheet. She just memorized only the thing we had to do, like, whatever.
Yeah, we did that. It's just the sheet is what you have to have memorized. That's the product. Yes, Hannah.
So, what's
Oh,
the-
look at that.
Hannah, go ahead.
What time are we leaving on Monday?
2:00.
So I will.
Yep. Yep, you'll have time to take that quiz. Yep. Spencer.
How about the trig identities?
Trig identities. Sine, well, all the ones. Sine squared plus cosine squared equals 1. I wouldn't forget that one. And remember, you can generate all the other ones from that.
Yeah, but none of us like to do that. We don't know how to do it.
I will make you guys a deal. I will make the answer key with no notes too, so we're on a fair playing field. So there we go. Okay. That's fair. See, I have to do it without notes. You have to do it without notes. I will make you a deal too. I won't even use my memory sheet.
Yeah, back when
Won't even use it. You don't want to see. You don't want to see the. You don't want to see my handwriting with that. All right. That's on Monday. Let's take a look. Example 1 today. We are doing these with multiple angles. Let's take a look at easy one or hard one. Let's go for an easy one first. Let's say you have that sine of x. No, 2 sine of x.
Hey, what's on our quiz?
What's that?
I never said that.
Easy. Okay, only proofs. That's it.
Ahem. Something we'll talk about when we have time at the end of class. All right, let's take a peek. 2 sine of 2x is equal to negative square root of 3. Now, here's the thing that's harder about this as you're putting your phone away. We have this now inside. Now we have something that's being multiplied inside of the sign. Now, of course, you know that means we're going to divide stuff by 2. Okay, that's easy. What you have to know is that this is going back to those trig graphs that we did. And we told you that b value, that thing inside the sign, was like a speed function. And it is. It's like a speed function. It makes the Ferris wheel go faster. It makes the Ferris wheel go slower. If you go twice as fast, you get to go twice as many times around. The problem with that is, too, it's going to give you b times as many answers. So, for example, normally this problem, between 0 and 2 pi would have 2 answers. B times as many answers. So normally between 0 and 2 pi, this would have 2 solutions. But because we're going twice as fast, now sine of 2x will have 4 solutions. So take the number of solutions you'd normally have, multiply it by b, and that's how many solutions you're going to have now that that speed function's in there. That's what makes this hard, because you have to take into account that there's not going to be 2 solutions anymore like what's on your answer sheet. There's going to be b times as many solutions as there normally is. So in other words, if cosine of x is equal to -1, normally there's only one place that would happen. If you're going 3 times as fast, you're going to have 3 times as many solutions. So there'd actually be 3 answers that we'd have between 0 and 2 pi. Why? Because remember, our graph is going 3 times as fast, so when we draw that dotted line of where we want to intersect it, it's going to intersect it 3 times as many times. The fun you all will have with Kellerman and Massey next year.
No matter what you're teaching, I'm in it.
No. Mrs. Severn, I swear, I don't need to take Calc AB. I can go straight to BC. Back when said I could. No. Okay, so let's take a peek at what this looks like for an answer. Let's go for this. 2 sine of 2x is equal to the negative square root of 3. Easy part. Normal rules. What do we do first? Divide by 2. Divide by 2. So sine of 2x is equal to the negative square root of 3 over 2. All right, that's fine. What's our next step? Yeah, no, now you want to divide by 2 because we'd like to have sine of x there, but we can't. There's a 2x inside there. So now we have to take the sine inverse. Here's the number one shot to make a mistake. The number one shot to err on this is you have to remember it's equal to 2x, not equal to x. Because when you take the sine inverse, you're actually not going to have your answer. You have to do something more now because there was a 2 inside of it. So you have 2x is equal to the sine inverse of negative square root of 3 over 2. Look at your memory sheet. Where is the sine of the square root of, where is the sine equal to the negative square root of 3 over 2? Which is 4 pi? Can't be 4 pi. 4 pi by 3, thank you. 4 pi over 3, or 2x is equal to, where else? 5 pi over 3. Okay, so I believe that's 210 degrees and 300 degrees. Is that correct? Okay, now here's the deal. That is the solutions if we just went one time around normally. So think, if the Ferris wheel is going a normal amount of times, where would you intersect that? You'd intersect it once there and once there. Now it's going twice as fast, though. So now you're going to go around that entire thing 2 times instead of 1. So what do you have to do with this puppy? Well, really the answer was 2x is equal to 4 pi over 3 plus 2 pi n, or 2x is equal to 5 pi over 3 plus 2 pi n. The problem is because we said between 0 and 2 pi for this, you think, okay, I only have to list those 2. But because we're going twice as fast, we are actually going to get more solutions out of this. In other words, we're going to find more angles between 0 and 2 pi. Let us solve this. So when you think of solving this, you need to think of that 2 pi n until you finish the problem off. How do you finish the problem off? Okay, what do you do to get rid of that 2? Okay, now we divide by 2 is going to be ugly with that. I'm going to think of it as multiplying by 1/2. Absolutely the same thing. So I'm going to multiply by 1/2. When I multiply that by 1/2, that becomes x is equal to 4 pi over 6. When I do that, 2 pi over n divided by 2 gives me just pi n. We're not actually done yet, but let's stop and let's check up because that's kind of heavy. Do you have to redo the 4 and the 6? Absolutely. So let's even put that as 2 pi over 3 plus pi n. Or, should have wrote or there too. X is equal to 5 pi over 6 plus pi n. Give you a little bit of instruction in just a second, but questions on getting to there, we're not done yet, but questions on getting to there. Yep, Josh.
Why did it change from the first to 4 pi over 3 plus 2 pi n, and the second to 4 pi over 6?
Because I multiplied both sides by 1/2 to get rid of that 2. So when I multiply that by 1/2, it gives me 4 pi over 6. Spencer.
Why did you say that you about the 2 pi n, you only have to think about it till the end?
You have to continue to think about it to the end because it has to be there, because we're asked to find all of them between 0 and 2 pi that would solve it, and there's going to be twice as many of them. So normally we just have those 2 solutions, but because we're going twice as fast, we're going to have 2 times as many, so we're going to have 4. How do we get the other 2? By adding a pi to both of these. Because we're going twice as fast, so we're going to hit it twice as many times. Now, where's the problem? When you go like 3 times as many fast, or 3 over 2 times as many fast, that's when it really gets ugly. Thank you. And warm up. Okay, so that's 2 of our answers. So answer number 1, answer number 2. How do we get the other 2? Well, we got to see, are there any others between 0 and 2 pi? So we got to add a pi in. If we add a pi, that's how many pi's over 3? Okay, so if we added 3 pi over 3, that gives us 5 pi over 3. Is that between 0? I added a pi. Because it's 2 pi over 3 plus pi n, so I could add any multiple of pi onto that. So if I go to the next one, I add a pi on. How many, if I have pi over 3, or excuse me, if I have it over 3 here, 1 pi is how many pi's over 3? 3. So what's 2 pi over 3 plus 3 pi over 3? 5 pi over 3. Is that between 0 and 2 pi? Yeah, we're good to go. So there's answer number 1. There's answer number 2. Here's answer number 3. If I take 5 pi over 6 and I add a pi onto that, that gives me 11 pi over 6. Is that between 0 and 2 pi? Yep. 1, 2, 3, 4. Now you may say, how do I know when to stop? What if I added another pi onto this one? And the 8 pi over 3, is that bigger than 2 pi?
Yeah.
Yes, it is. So it's not in the range that we're looking for our solutions. So this is how we generate all of those answers out. Nope, because it only asks for the answers between 0 and 2 pi, and there's the 4 answers between 0 and 2 pi. Why do you have to keep the pi on there? So that you know that that's what we need to add to find multiple solutions or to find the other solutions that are out there. Now, if you're really in a dark alley, you need to get this correct for sure. What would you do? You just try that out in the very original problem, which was this fun one, and make sure it gives you negative square root of 3 over 2. Excuse me, negative square root of 3 on the other side. Anyway.
So if you have a 2 in the front and then a 2 inside of the side,
Yep.
then does that mean you're always going to have 4 solutions?
Yep. So let me even make it worse for you. If you had the sign of 7x, how many solutions would you have at most? Well, normally we get how many from sine? 2. So if you're going 7 times as fast, you'd have 14, right?
Please never do that.
Okay. But then,
Nate, my job is to make you as smart as possible.
No, stop.
Yes.
I can't do this now.
Yes. Other questions on that?
oh, yeah.
Yes.
So there's a 2 in front.
Can't hear you. People are talking.
The 2 in front of the side.
Yep.
You would already have like 2 solutions if it were just like one side.
Remember, that just makes the amplitude bigger. It makes it go higher and lower.
Oh, okay.
So that means we could get actually like 2 as an answer out. Because the actual square root of 3 is 1.73. So if you just had sine of 2x is equal to the square root of 3, that can't have a solution because sine goes between -1 and 1. But because it's an amplitude of 2, that works out. So that's what the 2 outside does, makes the amplitude bigger. The 2 inside makes it go twice as fast.
Oh,
It's a speed function.
so the 2 outside doesn't actually affect the solution.
No, it just affects the range of the solutions that we could get, which allows the square root of 3 to be one of our solutions.
Okay, so how did it affect the range?
Because if you didn't have that 2 out there, you just had that as your original problem. Boy, it's just a good thing. Christina Ostovich, is that what you're doing on your phone this whole time? Boy, it's just a good, yeah, boy, it's a good thing Donald Trump didn't send that email. It would have just been a joke. So, Hannah, for those of you actually wanting to learn math and honors pre-calc today, if you didn't have that, if you didn't have that 2 in front, there's no solution. There's no angle whose sine is the square root of 3 that's bigger than -1. We would actually not have a solution if that 2 wasn't there. Because when you took the sine inverse of negative square root of 3, it'd give you an error because that's not the range of sine. How do you do? Yeah, cool. Yep. Other questions on that? Okay, believe it or not, that's an easy one too. So,
Really, who's Jamie Demeter?
Ostovich. Easy one or hard one? Let's do a hard one. So let's do example.
6 minutes.
Yeah. Guys, what do you got going on after school anyways? I mean, Coach Al would be fine. You gave me your trophy case. What could he say? You know.
You realize it's a game that rushes, right? So if I'm not there.
How's everyone doing?
I thought someone was missing.
Who is this? All right, let's do something that actually matters. Yeah, I know. These people don't even have pronounce. It's pronounced memes. Come on, people. Come on. All right, let's go for this one. All right, secant. Now we have some real fun. The secant function. Yes. No. All right, let's go. Hey, I'm going to take as long as this one takes. Hopefully it takes about 5 minutes. Okay, so the secant function. Okay, we go back to our trig proof. Secant means we need to probably take 1 over the what? Cosine, right. So we take 1 over the cosine of 4x is equal to 2. Okay, now that it's hard to solve for something that's in the denominator. What should we do to get it out of the denominator? What's that? Multiply both sides by the denominator or take the reciprocal of both sides. Either one of those work. Be careful if you take the reciprocal because if it's equal to 0, that's not going to work. Any other time it would, though. So let's take the reciprocal of both sides. So then we have cosine of 4x is equal to, what's a reciprocal of 2? 1/2. Stop and check up. Questions quick? Let's call in some victims here. Seth, what should I do then? Right, because now I got to find the angle whose cosine is 1/2. Look at your memory sheet real quick. What angle gives you a cosine of 1/2? Somebody say pi over 3.
Pi over 3.
Yeah, pi over 3 plus 2 pi n, right. 2 pi n or 5 pi over 3. Don't make it awkward. Plus 2 pi n, right. Now, we are asked to find, again, the solutions between 0. If we are asked to find the solutions between 0 and 2 pi, we actually got to figure them out. If they just ask us to find all the solutions as soon as we divide both sides by 4, we're done. But your teacher loves you too much to do something that easy. So let's multiply both sides by 1/4. Nate, one day you'll be happy that you had my class. Good. You and 14 other people. Okay, so x is equal to, okay, multiply by 1/4. That gives you pi over 12 plus, okay, 2 pi over n divided by 4 gives me pi over 2n. Over here, multiply by 1/4, x is equal to 5 pi over 12 plus pi over 2n. So normally this would have how many solutions? But because we're going how many times faster? 4, we're going to have 8. 8, right. Yay. 8 is great. Questions on that? Okay, yes, Cameron. Shh. No, go ahead. Okay. So what do we have to do? We have to keep adding pi over 2 to these until we get all 8 solutions and making sure they're between 0 and 2 pi. Now, again, if it just asked for all the solutions, there are all your solutions. You're done right now. But I love you, and I want you to be happy. Therefore, I make you find all of them between 0 and 2 pi. Hannah, quick, then let's finish.
Or in between the two solutions?
Because it could be these, or it could be these. Like when you factor something out, you get like x plus 1 times x plus 2. You should write x equals 2 or x equals negative 1.
Why didn't you say and?
Because it can't be negative 1 and 2 at the same time. It can be either at this one or at this one.
Oh, okay. Just think of it like a wheel, like you can't be here and here at the same time.
Right.
Oh, okay.
Yeah.
Oh, so, okay.
Future math teacher. Yes. The range would, can you elaborate on that a little bit? 0 to 2 pi, yes. Yep. Okay, so let's keep adding. Let's go. So pi over 2 is how many pi's over 12?
Before you finish, is this going to be on the quiz?
No, 6b is not on your quiz. No. We got to finish this first. You can't just leave a problem hanging. It's right there. It's like, no, that's like you're wide open for a layup and you don't shoot it. Yeah, you still got to shoot it. So. What?
And Reebok.
What?
Mr. Reebok emailed you.
Ben the man. Nice try. All right. Pi over 6. Okay, pi over 2 is how many pi's over 12?
6.
So you add 6 to how many do we have? Okay, so that gives you 7 pi over 12. Add 6 more, that gives you what? 13 pi over 12. Add 6 more, that gives you? Add 6 more, that gives you? 25 over 12, which is bigger than 2. We're done. Go to the other side. Add a pi over 2. That's 6 pi over 12. That's 11 pi over 12. Add another 6. That's 17 pi over 12. Add another 6. That's 23 pi over 12. Add another 6. That would be 29 pi over 12. No go. Okay, so let's review real quick. What's on your quiz? So you got to be able to solve them that don't have a b value for the trig function. Yes, if you need some practice on trig proofs, 6.2, they're easy trig proofs compared to what I gave you and tortured you with earlier this year. Like, look at this. Look at this. Tangent plus cotangent over tangent times cotangent is equal to tangent plus cotangent. Trivial. This is easy. Easy. Trivial compared to what you guys did. 6.2, you got to be able to find, like, if I give you the sine of an angle, the cosine of an angle, you got to be able to find the other 6 trig identities. If I give you the sine of an angle, and if it's positive or negative tangent, you got to be able to find 6 angles. No, can't. There's no time. It'll be on the video, though.
I guess there's no time.
No.
That's true.
And then
Text is when the video's
5.6. 5.6 is the inverse trig functions. That's the very first time we talked about, like, sine inverse, arc sine, cosine inverse, those types of things. Not that bad. Not that bad.
Wish you luck tonight since you don't.
Good luck.
I think